Infinitely above us, the cosmos stretches into the unknown, vast and mesmerizing. It is a realm that has long captivated the imagination of humankind, and now, Bill Nye breaks his silence on the most recent and extraordinary images captured by the James Webb Space Telescope, often misspoken as the James Webb Telescope. These remarkable visuals offer us an unprecedented glimpse into the universe as it existed more than 13 billion years ago. The implications of these images are profound, fundamentally altering not only our knowledge of the cosmos but also our broader perspective on life itself, the origins of existence, and our place in the grand design of the universe. This telescope, built upon decades of theoretical science and engineering ingenuity, is now actively making groundbreaking discoveries. It is peering into the furthest corners of deep space and revealing the existence of distant galaxies, previously unknown planets, and so much more. What we are witnessing is nothing short of a revolutionary scientific breakthrough, one that many scientists, including Bill Nye, believe to be a worthy successor to the Hubble Space Telescope. The capabilities of the Webb telescope far surpass those of its predecessor, particularly in the realms of infrared imaging and deep space observation. So, what is so special about the WSD, Webb space data, images that defied our expectations and upended long-standing astronomical theories? And, more intriguingly, what exactly does Bill Nye have to say about them? These are not questions that arise lightly. The creation and deployment of this telescope represent the result of years, indeed decades, of tireless work carried out by dedicated NASA scientists and engineers. Their combined expertise, relentless perseverance, and innovative designs culminated in the launch of this extraordinary observatory on Christmas Day in 2021, a date now etched in the history of space exploration. Following its historic launch, the various steps of the telescope's complex deployment proceeded smoothly over the next few months. Every stage, from the unfolding of its sunshield to the meticulous alignment of its mirrors, was executed with astonishing precision. By the end of June 2022, a monumental milestone had been reached. Scientists began to discover thousands of new galaxies, many of which were older and more distant than any galaxies previously known. Some of these newly observed galaxies might have formed as early as 150 million years before the Hubble telescope's oldest recorded discovery. This suggests that we are now peering deeper into the universe's infancy than ever before, thanks to the unmatched sensitivity and depth of the Webb's instruments. In addition to imaging galaxies, the telescope is capable of capturing enough light from celestial objects such as exoplanets and stars to extract detailed information about their composition and trajectories through space. This level of precision was previously unimaginable. According to Bill Nye, these datasets are already beginning to reveal, in extraordinary detail, the atmospheric compositions of planets located light-years away from Earth. These insights are so advanced that they allow astronomers and planetary scientists to make preliminary suggestions regarding the potential of these exoplanets to harbor life, as we understand it on Earth. One of the Hubble Space Telescope's most iconic images is that of the Pillars of Creation in the Eagle Nebula, a hauntingly beautiful structure of interstellar gas and dust. This structure was visible to the Hubble telescope primarily because it detects visible light. However, the intricate processes of star creation occurring within those pillars remained hidden, until now. They have now been captured by the Webb telescope's powerful infrared imaging system. The results? Breathtaking. In the form of many protostars, what appear as faint clusters of gas and dust, each one several times larger than our entire solar system. These stars in their nascent stages show up as tiny red dots set against the dark, shadowy background of the cosmic pillars. These are stars in the process of formation. According to Bill Nye, the stars visible in these photographs are not yet consuming hydrogen in a full thermonuclear reaction. They are instead gathering matter from their surroundings. As more and more material is attracted to the core of a protostar, it becomes denser and denser. Eventually, the pressure and temperature at the center become so intense that hydrogen fusion ignites. This marks the official birth of a star, causing a dramatic increase in temperature, often reaching nearly 2 million degrees Celsius. The resulting light emissions vary in color depending on the temperature and composition of the star. The different colors that appear in the Webb telescope's image represent various infrared wavelengths, most of which are invisible to the human eye. The only visible parts of these images appear blue. Meanwhile, the deeper hues enhance the red radiation in the image. This is because protostars tend to emit radiation at a wavelength 6 times longer than what human vision can detect. According to Nye, this image not only showcases the impressive infrared capabilities of the Webb telescope but also provides visual confirmation of how stars like our own Sun are formed within dense molecular clouds scattered throughout the galaxy. The first confirmed discoveries of exoplanets took place in the 1990s, opening an entirely new field in astronomy. Today, over 3,000 confirmed exoplanets are known to orbit distant stars. Yet, of this vast number, only a small handful, a dozen or so, have been directly imaged. This is primarily because most exoplanets are situated so far away from Earth that they can only be detected indirectly. Scientists rely on methods such as observing the slight dimming of a star's light as a planet passes in front of it. However, the first direct image of an exoplanet by the Webb telescope was taken in September of last year. This particular planet, first identified in 2017 and named HIP 65426b, offered a rare opportunity for direct observation. To capture the image, scientists used coronagraphs on the telescope to block out the overwhelming light of the central star. They combined this with two of the Webb telescope's cameras, a series of specialized filters, and other precision instruments to finally isolate and photograph the planet. HIP 65426b has several unique features that made it easier to detect. Not only is the planet exceptionally far from its host star, at a distance about 100 times greater than the distance between Earth and the Sun, but it also boasts exceptional infrared reflectivity. This massive gas giant is nearly 12 times the size of Jupiter, our own solar system's largest planet. Another remarkable image captured by the Webb telescope is that of the so-called ghost galaxy. This celestial object is difficult to see with the naked eye, but its brightness becomes prominent when photographed using an infrared camera. The galaxy, also known as M74, displays a delicate spiral structure with arms radiating outward from a glowing core. The optical view of this galaxy highlights its broad array of stars, while the recent Webb telescope image reveals intricate fibers of heat-emitting dust and gas, all emanating from a dazzling electric blue center. These filaments are areas of intense star formation. This new image will likely serve to illuminate the star-forming regions scattered along the galaxy's spiral arms in much greater detail than was previously possible. Furthermore, photos taken by both the Hubble and Webb Space Telescopes have been artfully combined to produce a stunning composite image. This image highlights the unique contributions of both instruments, Hubble's optical clarity and Webb's infrared depth, providing a holistic view of the galaxy's structure and activity. The composite was created by researchers at the European Space Agency, ESA, as part of the FANGS project, an international collaboration that uses Hubble, Webb, and several ground-based observatories to study 19 nearby galaxies in the infrared spectrum. Thanks to Webb's exceptionally sharp observations at longer wavelengths, astronomers can now accurately identify star-forming regions in galaxies, measure the masses and ages of star clusters, and even deduce the physical characteristics of the minuscule dust particles that drift through interstellar space. One especially intriguing image involves a distant star known as Wolf-Rayet 140. Taken in July of last year, the image displayed a recognizable diffraction pattern, a type of imaging artifact typically observed in telescope images. However, in this case, the star is also surrounded by an unusual pattern of wavy, concentric rings with a slightly squared shape. These rings, unlike the diffraction pattern, are natural phenomena. They are a hallmark of massive stars known as Wolf-Rayet stars, which are in the late stages of their evolution and have already expelled a significant portion of their hydrogen. The fascinating ring structures result from interactions between WR140 and its much smaller companion star. The interactions are not just aesthetically stunning, they are scientifically significant. They give researchers a deeper understanding of